Good morning, good afternoon, good evening to everyone. Thank you for joining the Beam Talk session for the month. You are welcome to today's event. Today we'll be having a session on the acceleration of machine learning in the construction industry. It's quite an interesting topic that I myself am very much interested in learning about. And our speaker today is Karthik, who is joining us all the way from Australia, actually. It's an evening time for Karthik at the moment, so we appreciate you for the sacrifice of the timing, and we'll start the session now. I'm sure that Karthik would introduce himself, and there will be a question and answer session after the session. While this presentation is going on, if you have questions, you may drop them in the chat box, and we'll then take the live question and answer session. Karthik, over to you.
Thank you very much, Moses. So it's time. So do you want me to get started?
Yes, please.
Okay. Welcome all. Like Moses introduced, I'm Karthik Venkatasubramanian. I am the Vice President for Data Science and Analytics in Oracle's Construction and Engineering Business Unit. I'm based out of Melbourne in Australia, so very, very far away. And I'm talking about a topic that is really, really passionate and that I'm very passionate about and really, really close to me. So you will find that a lot of the things that I'm talking about are hopefully resonating with your experience. So please make sure you're asking questions in the chat, and towards the end of this, I will try and answer them as best as possible. So like with any presentation, I just want to start off with our safe harbor statement. I will be making some statements. Please make sure that you check with us and not make any purchasing decisions. So we're talking about big data today, right? And one of the first things we need to talk about when we're thinking big data is, what does big actually mean? So what I've got on my screen here is 1 followed by 24 zeros. So 24 zeros is a yottabyte. That's right, a yottabyte. I did not know this until my son asked this question the other day, because we're creating a lot of data. But then my son asked another question. What happens after yottabyte? What is 1 followed by 27 zeros? Now, the answer to that question is quite tricky. It's called a brontobyte, named after the brontosaurus, because there is a lot of data that we're collecting. So when we're talking big data here, we're talking really, really, really big data. And what that means is, data is often compared to a lot of different things. You have all heard the expression that data is like oil, right? It is a valuable resource that has to be converted into something really useful. So data is the new oil, and that's something that a lot of people have heard. Data is like water, right? It nourishes, it's required, but if you have too much of it, you can drown in it. Data is like sunshine. It again nourishes. It's required for a lot of organizations, but when you don't channel it the right way, you can be burnt by it. Data is like rain. It's created in the clouds, comes to the earth. It's really, really useful, but at the same time, it can cause flooding and you can drown in it. Data is like uranium because it is unstable if you don't use it right. And data is like garbage, because if you don't have a plan to dispose it, then you should think twice about collecting it. So if you think about data, it's been called a lot of different things, and we're collecting a lot of data. So I think a session on big data always has to start with, what do we mean by big data? That's just a lot of data, a lot of things that we're collecting, right? And in the construction industry, we collect a lot of data. Let me show you an example from a product that Oracle owns called Aconex. This is the Oracle construction network for our product called Aconex. Each little circle there is an organization exchanging information on projects. The lines represent mails and documents that are being exchanged. As you can see, over the years, a lot of data has been collected, a lot, right? And this is the example of big data that is actually formulated in a construction project, because construction is itself extremely connected and very information intensive. But you might look at big data, you might look at this graphics and you might go, oh, wow, it looks too much high tech, right? It looks like we're at the cusp of great technology. But the reality is, construction is one of the oldest professions in the world. As you can clearly see, I've picked up some landmarks across the world. In fact, 2000 years ago, the Roman Emperor Julius Caesar actually appointed Vitruvius, who wrote a 10-book treatise on architecture, a 10-book. And the book talked about construction risks inherent in building. It talked about careful contractual articulation. It talked about water leakage and disputes and drawing up contracts and skillfully drawn ideas so that the project can be delivered on time. This was 2000 years ago. So construction is a really old profession. And yet, what we often see is that most construction projects have stats like this, the 3Ds. And the 3Ds I'm referring to here are not the 3D from a geometric model. The 3D that I'm referring to are delays, defects, and disputes. You will often find numbers like this. 35% of all construction projects will have a major change. 30% of the data that's created is usually lost by project closeout. 82% of the owners feel they need more collaboration. 78% think that the project risks are increasing. There's prioritization of immediate financial goals. And construction disputes take 17 months. These numbers in themselves aren't really that important, because depending on the source, you will find that these numbers change by 5 or 10%. What is surprising is that these numbers exist after all these years, especially when we are considering the technology that we have at the moment. But the problems that we have can be classified into 5 key buckets, and it's very easy to see why we do have those stats. So if you think about most projects, they care about 5 key things, right? Schedule, cost, quality, safety, and risk. The problems that people have often are delayed projects. There's cost blowouts, margins are really poor. There's poor estimating when you bid for a job. Contracts are not effective. Quality of the work isn't good, often leading to a lot of rework. Safety is a problem on site with incidents and near misses. And risk is a really big thing, especially identification of risk, mitigation, having a response. Now, I'm sure a lot of you are looking at this and going, I can relate to this because this is something that I live with every day, right, on construction projects. But you can also see why this problem exists if you try and look under the hood of a project. So what we did was we took a construction project and took a peek underneath the project to see the volume of information that goes on in a project. So what you're seeing here is the exchange of information between different parties on a construction project. You already know that there is a lot of data exchange. You already know that there's documents and transmittals and submittals and RFIs and lots of things flowing. But this is what it looks like in a 2 to 3 month period. There's a lot of exchange of information going on. And therefore, things get lost, things get missed, things get delayed. And therefore, we end up having the issues that we do. A lot of companies that we work with have taken action. They have been doing something to resolve these issues. I call it the Asian revolution, and I will explain to you why. Asian refers to an action or an instance of it. There's some form of standardization that is going on. We are standardizing processes, work practices, standardizing the way we carry about doing certain things on job sites. There's prefabrication, right, where materials are prefabricated before they're brought onto site. There's modularization that is trying to mimic manufacturing. There's integration, both from a system perspective, where the systems that are being used are getting integrated, and there's integration of supply chain. There's a lot of automation, whether that is through process or through technology or through systems. And there is systematization, which is just a fancy word to say that a lot of systems are getting implemented at the moment. That's the Asian: standardization, prefabrication, modularization, integration, automation, systematization. That's a lot of Asians, but we're not done yet. There's a lot of collaboration that's happening where people are working with each other, not just within a country, not within a region, but globally. And what that is leading to is digitization. So the one thing that we've learned from COVID is acceleration of digital technologies. Companies are accepting and implementing digital technologies like never before. That is leading to datafication, because a lot of these digital technologies and tools are creating a lot of data. That is now allowing reimagination of existing processes in ways that we were never able to imagine before. And that's leading to transformation, right? Fundamental transformation of how the business works, how projects are delivered, how processes are executed. There's a huge transformation. And that's what innovation is all about. And fundamentally, what you're seeing is innovation in action. Now, some might argue that the transformation is long overdue. Construction was named a laggard a few years ago from a digital perspective. Construction was just after hunting and farming from a digitization perspective. So the transformation that we're talking here is long overdue. Therefore, the innovation is going to be radical innovation. It's not a step change, it's a big change, right? So the Asian Revolution is a way for us to step forward and resolve some of the issues that have plagued us for many, many, many years. But when you look at the construction technology of tomorrow, there is a lot of fancy technologies out there. In fact, a lot of us have seen these technologies in movies. Think robots from Terminator, AR and VR from Minority Report that Tom Cruise starred in. There's wearables, like if you have seen Inspector Gadget and cartoons from back in the 80s. There's smart materials that are coming from Transformers and other places. There is a lot of technology that is out there at the moment. This is our own technology at play. This is Spot, and this is in our innovation lab in Chicago. Spot is carrying out an inspection and making sure that any inspection defects are filed away very well. There is a lot of technology at play these days. But what is happening here is each and every one of this technology is creating more data. You know, back in the day when I first started working in data, when we spoke about data, most people imagined it like this: ERDs, entity relationship diagrams, things that are connected like this. But these days, we talk about data like this. This is the same network diagram I showed you right at the start. This is a lot of exchange of information on capital projects. So the concept of data has changed because of big data. And what that allows us to do is machine learning. Use machine learning and build artificial intelligence systems that can help in decision making. And that's the type of question that we're trying to answer today. We have lots of data. There's a lot of risk. So how do we bring it together? How can we accelerate data-driven decision-making to transform capital project delivery? How do we use new emerging tech like AI and machine learning in construction management? How can we provide and simplify the provision of actionable insight? And how do we use data to rethink the status quo in a post-COVID world? So we were trying to understand and answer these questions. And one of our solutions from Oracle is a new solution that we released called the Oracle Construction Intelligence Cloud. It's an AI advisor for construction projects. So we launched it about 3 weeks ago. And what I thought we will do is, when I'm talking about ideas and concepts, I will show you our screenshots. I will show you our solution so it becomes real. A lot of the times when we talk about machine learning, when we're talking about AI, it can feel very superfluous. It can feel like it is artificial because it is a concept. So what we will try and do is we will try and make it real for you so that you can see what we mean. So Construction Intelligence Cloud is about using AI, but what does that actually mean? We already use AI in everyday life. So if you've got a mobile phone today, there is a bit of AI there. If you use a movie streaming service, there is a bit of AI there. Music, AI. Social networking, a bit of AI. Because it's making recommendations. It's predicting the text you want to type. It is deciding which turn you want to turn in your navigation. There's a bit of that incorporated in our everyday life. So all we're doing is taking those concepts and using it on a construction project. So think about a project that you're doing. Let's imagine a rail project. And we are saying, how can you use data to drive decisions and outcomes? More specifically, how can you plan smarter? How can you predict risks? How can you prevent issues? And how can you deliver faster, better, easier, right? So everybody delivers projects that are in construction, but how do we make it better for the people involved? But there's two other things that are really important here. How do we make it safer so there is less accidents, there's less near misses, less safety issues? But most importantly, how do we deliver a project where everyone's actually happy, right? The employees are happy because you're actually working on projects that you're really proud of. It's safe, you enjoy the experience. Contractors are happy because they're making money, they have a good workforce. Owners and governments are happy because they're getting the output that they want within budget. So happiness is a factor that we think is really important because AI and machine learning can feel otherwise quite dry. It can just become about the data and we don't want it to be that. So let's explore how you would go about doing some of this. So the first example is everyone starts these projects with a schedule. There's some form of schedule somewhere, right? You have start dates, you have finish dates, you have actuals, you're tracking a project. So think about this. How do you minimize schedule delays on every single project? Ask yourself these questions on the jobs that you're working on your current project. Think about this and ask yourself, is the schedule built right or does it have errors? What is the probability of delay on the project and how many days will the project be delayed by? Now, there might be some of you that might go, well, I know the answers to these questions. Some of you will go, why are we talking about delay? My project's on track. But that is one of the things that we're trying to address is always think about delay so that you're one step ahead. Ask yourself, what activities are predicted to be delayed and by how much? What factors are contributing? What's the source of data and how accurate are your predictions, right? But fundamentally what we're trying to do here is use AI-powered delay predictions to take preemptive action and keep the schedule on track because that's the most important thing. So I hope you will think about this in the context of your project and say, I can answer 3 of these questions or 5 of these questions or none of these questions. The important thing is, are you asking these questions? Let me give you some examples of screens and solutions from our product. So for example, we're talking about the chance of delay. So on this particular example, we're saying there is a 65% chance of delay on this project. We want to be able to show why are we making these predictions? What are the reasons that this project might be delayed? It probably doesn't have enough number of activities or it's missing some activities that we think it needs to have. It probably doesn't have enough resources assigned. There could be a whole bunch of different reasons. So what we're doing here is we're using AI and machine learning and using things like decision trees and random forest and XGBoost, if anyone's interested in the technology, to be able to say, what is the probability of delay on this project? And we want to identify where the delays are going to come from. What are the activities that might cause the biggest delay? Because you can take preemptive action. We want to be able to show for all the activities on your project, of which there could be thousands, where do you need to focus your attention on? There might be some activities that have already been delayed, and there are some that might be predicted to be delayed. We want to make sure you're able to look at what might be predicted only because that's where you can take preemptive action. Like for example here, This particular activity was planned for 10 days, but we're thinking that it's going to take 44 days. Our predicted duration is 34 days more than the planned duration here. And we want to be able to highlight this on projects so people can go take action. Sometimes you might ask, okay, that activity is delayed, but I also want to understand the downstream impact. So what we're trying to do is we're trying to show new visualizations that will help you understand the context of a delay in relation to everything else that's happening on the project. So think about those little dots and a lot of exchange of information. How does this delay affect other activities? So this delay here has an effect on several other activities that are happening on a project. This screen on the left-hand side, the image, is just a network visualization of a Gantt chart. Anyone that's used Microsoft Project, P6, Oracle Primavera Cloud knows a Gantt chart. What we're trying to do is we're trying to visualize that differently to understand what is the downstream impact when certain things are predicted to be delayed. So again, the focus here is what might be delayed and how do I step in? We're using machine learning, we're using AI, but the focus is trying to deliver the project on time using technology. Let's look at another one. How do we learn from the past? A lot of organizations that we often talk to have delivered a lot of projects similar to the one that they're working on. So are they asking these questions? How does the current schedule compare to industry standards? How does it compare to projects that are previously delivered? Imagine if you've had 5 projects that you've done before, or 20 or 1,000, you know which are the good projects and which are the bad projects. How do you use the projects that were delivered well? That's the question we're trying to answer. How do you learn from it? What were your most delayed activities and what activities have been delivered ahead of schedule? Who are your best and worst performing supply chain partners? And what changes do you need to make to your current schedule based on your historical data, right? This is about using advanced analytics to learn from the past so that you can make changes to the present. It might not necessarily be AI and machine learning, but the data that a lot of companies have is probably the most valuable asset that they have to make a start and then use it for AI and machine learning. So ask yourselves this: if your organization has delivered projects in the past, how is that data being used today? If you're working on a new project today, if you're bidding for a work today, do you use any of those historical data? If you don't, then this is a great starting point, and I'll explain why in a little while. So what are the types of things that we do with this data? We create project comparison groups. You can create different project comparison groups to say, these are our successful projects, these are our delayed projects, so that you're always comparing your current project with historical project. You can make a lot of other comparisons like this, where you can look at labor units, you can look at activity delays, 15 to 20 different parameters, and compare current project to previous project. Now, obviously, I'm not going to go into all of these different things, but the idea of comparison means that right from the start, you're always saying, am I estimating it correctly? Am I bidding correctly? Am I winning the job that I can actually deliver? Am I planning correctly? Have I learned from the past, from the data that I have? And I think that's the most vital thing that we're trying to address here. The business of prediction can be quite tricky. We're talking about making amazing predictions, and predictions are hard. Think about weather predictions and weather forecast. Most people are looking at it. They don't believe it 100%, but they know that having the prediction means that they can plan their day better. They can plan a construction job better. And that's what prediction is, right? It is a possibility of what might happen in the future. So it allows you to plan. What we're trying to do is make it easy. So you ask questions like, how do we improve the quality of these predictions, and how do we train and learn off our data? So I spoke about historical data, data that you have from old projects. How do you train off that? And how do you learn from that? So machine learning requires a lot of data, a lot of historical data to be able to learn from. And we use that data as training data to build models. How do we know what features are important for predictions? And features here refer to things that are input parameters, things that you send into a system so that a model can be created. And how can you create different models for different problems? Each of the problems that we're discussing today, they are all different. There's schedule delay predictions, they are trying activity delay predictions, and you will see some more examples. So each prediction problem has a different model. How can we enable everyone in the organization to use these predictions? So this does not need to be just purely theoretical or something that's very complex that only a few people understand. So what we have been really focused on is simplifying machine learning so that it's easily accessible. I will try and run through this entire presentation without using any complex scientific machine learning terms, because often what happens is when the technology takes over, the business takes a backseat. So we build models, and models are things that are looking for patterns. We use regression analysis, classification, clustering, all these types of complex things. But what they are doing in the end is they're helping you deliver faster, safer, better projects. And that's what we want to focus today on. So we have a thing called as a machine learning workbench. And what we've said is, you don't need to know coding. You don't need to know Python or R or any of the standard machine learning jargons. If you can pick a value from a dropdown, if you can click and select the parameters or the inputs you want to go for a model, you are ready to use this tool. So one of the things we are really keen on, and I think a lot of big companies in the world are looking at, is how do you make machine learning easy to use, accessible, democratize it so that everybody can use it, so that you don't need to know all of the details to be able to use it. That's something that we're really focusing on. But the other aspect to this is, how do we uncover hidden risks? There is a lot of data that you have within your organization. Think about this. If I asked you this question, could your current project end up in disputes and litigation? Is there a risk of rework due to incorrect documentation? How many of you would know the answer? How many of you would say, I know where to go looking for this? These are really tricky questions because they're not really easy to find, because the answer might be hidden somewhere in the data that we're collecting. What about these ones? Are there early signs of health and safety issues that need to be addressed? Or is there a risk of unexpected change and variations that will impact the budget? Are there some partners that are causing fragility in the network? They're holding up a lot of information. There's too many things that are outstanding and overdue. How do you use the power of AI to uncover hidden risks so that they can be mitigated proactively? That's what we're trying to do here. Let me give you some examples. This is the Florida International University. It's a bridge that collapsed a few years ago, and unfortunately, a few people lost their lives. What is interesting is that before this sad event happened, emails like this were exchanged, where people were talking about their concerns about the growing cracks with photos. Now, this is data that can be tapped into so that people can be made aware of the risks that might happen on a project. In the world of machine learning, we talk about it as NLP, natural language programming. There is NLU, natural language understanding. But fundamentally, what we're doing is we're looking at text and photos and images to try and understand if there is an issue that we can surface up. If you're in the world of computers, you would know this terminology, WYSIWYG. What you see is what you get. I created another term, which is WYSDY. What you don't see will hurt you. Let me give you an example. A lot of the dots that I showed you before, where there's exchange of information, this is what was going through their network. Document, change, detail, design. But what perhaps a lot of you can't see here is the little bits in red because they're really, really minute. Let me blow them up for you. Dispute, law, court, prosecution. And this is what we're trying to pick up through machine learning, because if there is conversations going on about it, concerns being raised about it, we want to be able to pick it up and highlight it so that a preemptive action can be taken. Think about this from a health and safety perspective. People are talking about a fall risk. People are talking about being struck with something. There's collision, there's hazard. What if we surface this up? So a lot of our focus has been in using this to separate the signal from the noise, to be able to produce screens like this that shows you where the risk hotspots are from a health and safety perspective, from a litigation perspective, from a dispute perspective. So you can jump in and look at what's going on and if you need to take preemptive action, because we know that the sooner you take action on some of these, the better it will be for the project, for the individual, and literally for everyone. And that's what we're trying to do with machine learning. I spoke about the fragility, and I said this statement right at the start that construction supply chains are extremely connected and very information intensive. Think about this. For your current project, do you have a visualization like this that shows all the organizations that are involved, the exchange of information that happens between these different organizations, and answers to questions like this? Who are your best and worst performing partners? Who are the most critical? Who are holding up most information? The more information you have, the better your ability to deliver. And that's what we're trying to do. This is called graph analytics. There's social network analysis. There's lots of technical terms behind it. But fundamentally, what we're trying to do is use the data that's captured on your project across multiple different things and surface up insights so that you can take action. But a lot of the things here we're talking about fundamentally comes down to three things. It's what I call as approaching to zero. We want zero health and safety incidents and near misses, zero disputes and litigations, and zero cost overruns and unexpected issues. We know machine learning is successful when we hit that zero. And we want three more things. We want accurate estimates so that we can deliver successful bids. We want projects that are delivered on time. But most importantly, we want to exceed customer and employee expectations. So the power of machine learning is not in its model, not in the data, but in the outcomes that it can achieve. And this is some of the examples that we think are really, really important in terms of achieving those outcomes. But when we talk about machine learning in construction, it's basically about change. A lot has changed because you need to look at your data. You need to trust it. You need to start to believe in these systems. You need to be able to create these reports and dashboards and visualizations. You need to be able to take action. Now we know change. This is the Primavera floppy disk from 1997. Clearly today we talk about the cloud and a lot of other things. So we know a lot of things have changed over time. But if you're wondering, what does this mean for my organization? Think about the data lifecycle, the data collection process. The data is created somewhere. It's created in a scheduling tool like P6. It then needs to be collected. So when you have different systems, you need to collect it somewhere because your original system just creates it. You're creating an RFI, you're creating a schedule. You need to collect all of the data, maybe in a data warehouse, in a data lake, in a database. You need to consolidate it because you have multiple different systems. You have one for scheduling, one for project management, something else for managing safety and risk, your ERP and finance system. So you need to bring it together and you need to consolidate this. You need to convert it into something smart because data on its own isn't really smart. So you need to convert it into reports and dashboards for insights and intelligence. And you need to keep it ready for consumption. Now, consumption is really hard because one size does not fit all. Depending on who your consumers are, you need to create different things based on their jobs to be done. It could be a project director, it could be a scheduler, it could be a cost controller. So depending on who it is, you might need to do something different. But what often happens with these things is they're easy to put on a PowerPoint and explain because it looks nice and neat. But in our experience, what typically happens is a lot of confusion. And there's confusion for a whole variety of reasons, because this is easier said than done. Some of the reasons we see our confusion for is that the data is dirty, right? Because there is one system that does not talk to another system. There is some things that we don't really understand why it is the case. It's missing, this piece is not the same as that piece. We're missing this data from that particular system because they're all siloed. We're using different systems. They're fragmented. The project IDs don't match. Organization IDs don't match. We can't really align. It's complex and messy because there is huge volumes of data. If you're looking at this and saying you can relate to some of this, this is what we hear from customers all the time. And that's okay, because large part of AI and machine learning is about making a start. And that's why this saying is really, really relevant, that a journey of 1,000 miles begins with a single step. You've got to make a start somewhere. So pick something that makes sense, where you think you have the data, and start. So what does the data journey look like? Well, the data journey looks like this, right? You start with reflective analysis. Think about this as focusing on what has happened in the past. You look at baselines and benchmarks, the lessons learned, some of the examples that I was just talking about today. You do descriptive analytics, which is about real-time reporting and dashboards. The focus is what's happening here and now. But where it gets really interesting is when you start to do diagnostic analytics. You ask why? Why is it happening now? You're doing root cause analysis, what ifs, exploratory analysis. And often that leads to predictive analytics. And that's what we were talking about today, right? Where we're looking at what might happen in the future. We're thinking about forecasting, simulations, machine learning. And therefore we get to prescriptive, where we say what should be done if what we think might happen happens. So think about this in the examples I was talking about. You have a prediction where an activity might be delayed. Therefore, you take an action. And because you take an action, the project or the activity is delivered on time. That's what we're talking about here. Now, what we find is that the bit on the left-hand side is often something that a lot of people do. This is your reports, your dashboards, basic analytics. It uses structured data. The bit on the right-hand side, that uses advanced analytics, machine learning, the examples we were seeing today. It uses unstructured data. It uses text, images, video. A lot of customers do this already. In fact, most organizations have some form of reports or dashboards that they use. But where we think a lot of the change is happening is on the right-hand side. This very session is about that, the right-hand side. How do we make predictions? How do we get prescriptive? How can we make recommendations? And that's where most of the focus is. And the benefit of doing this right is huge, because you're protecting the most important things you have. That is the people in your organization and the data. We think there's like 6 intangible benefits with machine learning and AI. It allows you to rethink job allocation. So think about this. All of a sudden, your machine learning algorithm says this activity might be delayed, or there is a health and safety issue there. You might need to reprioritize work and change your plan because something unplanned has been picked up. It allows you to strengthen cross-team collaboration because data doesn't care about silos. Like data doesn't care you belong to the scheduling team or the cost team or the bidding team. It just picks up insights. So it allows organizations to break down their boundaries between different functions. It helps transform key business processes. So one example of that is where you're looking at a current process using historical baselines and benchmarks, and you're saying, why are we doing it like this? So the more data you have, it drives business process improvements. It embeds learning into the organization's DNA because you're forever learning from historical data. You're making predictions based on what has happened in the past. You're using baselines and benchmarks. So there's this process of continuous learning that happens even without a plan. And that's the beauty of this. It allows you to change the way the business will run in a post-COVID world because there's a lot of digital disruption already. And it allows you to accelerate that change. It opens up a whole new world of possibilities with data. So machine learning, AI, these are all fancy terms, but what it really does is open up possibilities of things to be able to do that you just cannot do without it at the moment. Think about everything that's changed over the last 20, 30 years with internet. The next 20, 30 years, AI and machine learning and the advancements of technology, especially with compute power and storage and cloud, it's going to be absolutely game changing. So we think it's a huge opportunity for organizations to jump in the bandwagon. So that aligns beautifully with our mission. So at Oracle, our mission is to help people see data in new ways, discover insights, and unlock endless possibilities. I hope I've been able to show you some examples of that. There's a lot of interest in this sort of technology, so please feel free to reach out to us and we can walk you through more of the details. And I want to leave you with one little note. This is the bits and bytes version. This is what the machine sees. And while this is a machine learning session and we're talking about AI, the human reads this as thank you. And I think that's really, really, really important. So our focus is on still keeping the human in the loop. Therefore, we think artificial intelligence is really about augmented intelligence, where humans are still making the decisions. Machines are helping us on making them easier. With that, thank you very much. And we might open it up for questions.
Thank you so much for the presentation. It was amazing. I personally have learned a lot, and I hope you, the listeners, have also learned a lot. There's a question from Prakash saying, hello, how is AI or machine learning helping in making accurate estimates? How is artificial intelligence or machine learning helping in making accurate estimates?
Sure. So that's a really good question. So artificial intelligence and machine learning helps in making estimates better because it uses historical data. So think about your previous estimates that you've done for different jobs. At its basic level, it can look at a particular job. Let's say you have a new project, which is a $2 billion rail project. It can look at historical $2 billion projects and make recommendations on the quantities to put in, the estimates to use. The historical data can also help drive your schedules. What is the duration you need to put in for different things? So think about it like this. There's two ways to do historical data. One is the descriptive analytics that I spoke about, which is just using the data and making decisions. And artificial intelligence adds a layer to it. It says, okay, for the 15 times that you've put in a particular number, 2 times it was good, 5 times it was bad, 8 times I really don't know. So we can use things like regression analysis and clustering algorithms and classification to actually make the estimates better and accurate. So I hope I answered the question in the simplest way possible, but as long as there is data, there's something we can do with it.
Okay, thank you very much. Let me
Any
go
other
to the second
questions?
question. Yeah, there are
Nelly?
about 5. There are about 5. Let me go to the second question. Ritmwa says, in order to build a model pending on the problem you want to solve, one will need
I can read the questions myself. So I think Ritmwa says, in order to build a model pending on the problem you want to solve, One will need large amounts of data, but then most times these data is not readily available. What do you do in this case? That's a really, really good question. The question really is, what if you don't have the data? Now, think about this. How many companies don't really have any data or don't have data that's easy to use? Because if you're a new construction firm and you really don't have any data, then that is a problem. And probably machine learning is going to be hard. But what we often find is a lot of companies do have data, but they might not have it in a system. They have it in a spreadsheet. And if you have the data in a spreadsheet, in a file folder somewhere, in an archive, in a database, that's good enough to make a start. So I think it's really about saying, do you have any data to start off from and then build on it? Most companies don't have all the data to start off from. Therefore, when you start machine learning, your prediction accuracy will not be very high, but it will get better over time. And that's why I was talking about weather forecast, right? The weather forecast accuracy has gotten better over time. So 20, 30 years ago, the 5-day accuracy of a weather forecast was 66%. Today, it's about 88%, so 5-day weather forecast. So things get better over time as you have more data, but making a start with whatever data you have might be a good starting point. Nelly?
Okay, there's also the next question, talking about garbage. Sorry. What are the limitation of this limited construction
Any other
machine?
questions?
Yeah, on the chat box, there are quite several. Are you able to read?
Okay, I can see a few here. What are the limitations of these listed construction machine, and are there any disadvantages? Are there any disadvantages? So I think the way to look at this is the disadvantage is that you can get a false positive. So the machine can pick up something and think that it might be delayed or it might be an issue, and it probably is not an issue. So perhaps the biggest problem that you might have is that it makes an incorrect recommendation. But more often than not, that is fine because you need to think about it holistically in the context of your project. If it makes 3 incorrect recommendations and makes 5 correct recommendations, the 5 that it makes correctly will be more than making up for the incorrect ones, because it might prevent an issue, it might prevent a dispute, it can make a lot of change. So perhaps that's the biggest disadvantage. And the limit, and the other limitation that that someone's asking here, Yunusa, is the data, right? The quality of the data. So if the quality of the data is not very good, it will take time to start to make good predictions. But I would often recommend that it's easier and better to make a start and then try and make the data better than wait for the data to get better. Because as long as you keep waiting, it's a chicken and egg problem. The data never gets better. You're forever waiting. So that's what we recommend. We say that if you've got enough data to start, let's start somewhere and then keep making things better. I hope I've answered that question. I feel that a lot of data garbage and data dump yards are being created with the use of digital means, so a lot of efficiency would go into cleanup. How do you think the techniques mentioned by you would enhance the efficiency in the AEC industry? That is really good. From Ambarish, I agree. There is a lot of data that is being created from a lot of different systems. Now, how the data is used makes all the difference between whether it ends up being garbage or whether it ends up being useful. So think about the data that is collected on your computer, the cookies. Now, you yourself might not find much use of it, but yet when your password is remembered or the sites that you visited is remembered, or when it recognizes you, there is an ease, there is a comfort, right? It can be considered as garbage and not really good. So I think what is happening is a lot of the new age technologies are creating a data footprint, a digital footprint. How we choose to use it is going to make all the difference. So if we don't use it, it's just going to hog up a lot of storage in some place. But if we can connect up the dots, if we can connect up the data from the different systems, it becomes very, very powerful. So I talk about this idea of 360-degree view of what's going on in a project. And that's what happens when you have data from multiple different sources. So a slightly long way of saying that if you can connect up the data and you put it to use, you get a very powerful capability to make some use out of it. But if the data isn't connected, isn't used, then I completely agree. It's probably of not much use. Civil engineering, how can learn more about AI and machine learning? There is, if you Google up AI and machine learning, literally every field of construction, civil engineering, lots of work is being done around this. So, I'm speaking to different people around the world. One recently, they are predicting landslides. They are predicting soil cracks and road erosions and cracks in roads that might appear, maintenance, a lot of things that typically has been left to expert judgment are now relying on machine learning and AI. A lot of the times they're relying on computer vision, use of images and videos to be able to make those predictions. So there's lots and lots of examples of use of civil engineering, in addition to things like generative design. So when you're originally designing something, you can use AI and machine learning models to make different design options so that you can select the best one. So every little piece of the puzzle is and progressively getting more and more impacted by data and AI and machine learning. What and how the data could be collected for the development of AI and ML models. So I think there's a lot of questions around the data and where can it be collected. I think ideally it is collected in a database, in a data warehouse, in a data lake. But if you have the data in an MS Access, in a spreadsheet, in a system, that's good. Look for the export button. If you can export it, you're making a start. Right? Because often there is no one simple answer to this question. Sometimes there are companies that are very sophisticated and they have a lot of integrated data set. A lot of the companies have Excel spreadsheets. Depending on where you are, you say, okay, what is the data that I have and how can I make use of it? In another presentation, I actually talk about the data menu. You can look at schedule, cost, quality, safety, risk, and scope and say, what data do I have from each of these functions? And how do I integrate them to do something better? So that's one way of looking at it. Just do an inventory check, a data inventory, and see what can be done with it. Hope that answers the question. How affordable or accessible is this innovation? Really good question. So one of the things we've really focused on, at least from an Oracle perspective, is to make this affordable, right? I often say that that particular solution I was showing you costs half a data scientist. Because we have the cloud, we have access to the technology, and we have teams, we can build scalable solutions that might be hard for individual organizations to build on their own. So more generally though, compute power, memory, storage, everything has been getting cheaper over the years. So I think the technology has become more affordable than ever. In fact, one of the reasons why there's a huge uptake of these technologies these days is because the cost is decreasing. 20 years ago, we could have talked about these concepts. In fact, a lot of the algorithms, the maths behind these algorithms have existed since 1960s. But it was not possible actually to do it because of the cost associated with running some of these algorithms. Today we can. So in general, the cost has been decreasing. Therefore, it has become more accessible for a lot of people. How affordable or accessible? Yes, I answered that. Small scale organizations, absolutely. I think affordability in general is getting better and better over time. Can you please share a real life example of a prediction made by the AI or ML system? Yeah, sure. So real life example, as in I can't name customers or anything, but the most common predictions that these systems make, like this example here, is predicting that a project might be delayed by X percentage. And it says that it's these 3 activities that might be delayed. And these activities are going to be delayed because historically that activity has never completed. So think about it as concrete pour. historically, this particular activity has never been completed in 10 days, and yet you've put 10 days again. So it predict, like I showed you in the example, it said that it's not 10 days, it's going to take 25 days. So in real world, it changes from customer to customer, schedule to schedule. But all the features and functionality that I was talking about, they're all real. Like if you have a project today and if you have the data, you will start to see some predictions. Eunice, I'll let you ask the questions. Yes, I think ATAR is concerned on newbies. How much time do you think it will take for things to get stabilized and of real value? That's a really good question. So how long will it take? That is a complex question because it depends on where an individual organization is at in terms of their data processes and their data journey. Collectively, as an industry, it might take a long time because this is a huge global industry. It's one of the oldest professions in the world. It's also the least digitized in the world. So it will take a long time. But because the industry will take time does not mean everybody sits behind the 8 ball. It means that it gives us a huge opportunity to leapfrog. So I think what will happen is that a lot of companies that we are working with at the moment are playing around with these technologies, are trying to use these technologies for different things. And when one company uses it, it has a knock-on effect on others. There is a network effect. More and more companies come on board. And I think that will start to make a difference. While I can't tell you how long it will take, I think the best way to look at this is it's available now. Do you want to make a start? And that might be the best way to do it because I think it will start to flow through. I think about it as like dominoes, like as one starts to fall, the other starts to fall and everybody starts to use it and everybody starts to feel it. Think about, how mobile phones and, Android and Apple and everything got adopted. It will probably follow a similar product life cycle, but it'll take a little bit of time. Is BIM integrated with your solution? If so, how is it? So BIM is not integrated into the solution I was showing you right now, but we do have a BIM offering, and integrating predictions into 5.6D ND is something that we are looking at and thinking about. So you have geometric models, you're adding in schedules. So we're looking at how to add in predictions and other things into a BIM model. So it's not there yet, but it's something that we're looking at. Anything done on the digital twin platform from Prakash, especially facilities management? Yes, we are talking about it. We are discussing it. One of our products, Oracle Aconex, has a model coordination feature. So you can upload models and you can do clash in the cloud and you can detect things. And we think that will form a basis for digital twin, but we don't have something immediately straight away to show you. And that was not what I was going to cover today. In building a solution for predictive cost estimate, what low-code platform is advisable? So there is a lot of different cloud providers that provide different AI and ML functionality. Now, low-code or no-code, both are options. So you can use low-code environments that any of the major cloud providers do. We have our AI and machine learning service that is absolutely brilliant for this. Oracle has a thing called Apex, Application Programming Exchange, that is really, really powerful for low code. You might want to consider no code options as well. There are tools that will allow you to import the data, drag, drop, create models. So there's many different technologies that are available. Predictive cost estimates, again, one of the earliest one is an Excel spreadsheet. You right click, you draw a trend line, and you get an R-squared value. That's basic regression 101. So there's multiple different tools to do this. So depends on where you want to start. Big data and global adoption, what are the risks? So I think the biggest risk is not adopting it. There was a period of time, I think a lot of companies were saying, is this a passing fad? Is this something that is just coming right now, but it will go away? And I think what has happened with COVID and the pandemic is people are seeing that this is real. It is here to stay. Digitization is a real thing. This Zoom that we're talking in is absolutely real. And this is more and more of the future. So I think it is here to stay. What are the risks? The risk is there will be heavy reliance on technology. And as there is heavy reliance on technology, we need to still remember that Humans and us are still making the right decisions using the technology. We are using the data to make the right decisions. We are looking at the recommendations, but we are deciding what recommendations to choose. So think about movie recommendations, music recommendations. You can look at them, but what you choose to do is still a decision you need to do. So I think that is really important, that as we adopt a lot of technology, as we go through this process, we still remember how we play a really, really important part. And I think that's a risk we need to keep in mind. There are other standard risks that people talk about, which is absolutely vital. Security is really, really important. Data security. So at Oracle, we are really big about data security and the protocols. So we need to make sure the data is secure. We need to think about bias in the data, that the models that you're creating that uses historical data isn't biased, because the more biased it is, the harder it is for you to get right answers. So there are a few common risks like that, but yeah, I'm sure if you do some more research on it, you'll find a lot of risks with AI and machine learning. And the last question from Ambarish: are the solutions suggested by you fall in BI or BA category? So I think the way to look at this is, these are all terms, right? The way I look at this is business intelligence, business analytics. This is about using structured data. So in the examples that I gave you, using organizational baselines and benchmarks would fall under BI and BA. Some of the other ones wouldn't fall under that. So the simplest way to think about it is, if you're using structured data, if you have data in rows and columns and you're creating reports and dashboards, that would fall under BI and BA. But if you're using unstructured data, you're using text, you're using images, you're using visual videos, you are using audio, then you're using AI, and that would be completely different. You would still be creating reports and dashboards, but I think about it as BI uses reports and dashboards. AI gives you insights and intelligence. So I try to distinguish it like that. I think I have answered all the questions, and we are right at the top of the hour. So I will hand it back to the organizers.
Wow. Wow. Thank you so much, Mr. Karthik. And we would want to appreciate Oracle Construction Engineering for supporting us as Beam Africa. And I would also want to relay that we always have...
I can't hear from anyone, so I think that's pretty much it. Thank you very, very, very much. You know where to reach us. Please feel free to make a connection on LinkedIn, reach out to us, and we'd be more than happy to chat to you. Thank you very much.
Thank you so much, Mr. Karthik. And from behalf of Beam Africa, we thank you a lot. We thank Oracle Construction Engineering for supporting us. And we would want to also relay that we always have Beam Talks monthly. Here, we shall be communicating and passing out the communications to all our platforms. And we'd also want to appreciate everyone for joining in for today's Beam Talk. Thank you so much, everyone, for your individual input to make this edition possible this month. Thank you so much from Beam Africa. We love you and we thank you for your support. Thank you so much, everyone.